Deep learning, you hear about it everywhere. It's the engine that's powering the AI, completely reshaping our world, from how we work to how we play. But how does it actually learn? Well, in this explainer, we're going to pull back the curtain on this amazing technology.
So let me just start by asking you a question. Seriously, take a second and think about it. How many times have you used AI this week? Because whether you realize it or not, if you've used your phone or the internet today, the answer is probably a lot. This isn't science fiction anymore, you know? It's completely woven into our daily lives.
I mean, you've totally seen this stuff in action. It's the AI assistant helping you polish that email. It's the tool that generates these incredible images from just a few words. And yeah, it's the algorithm that can beat the world's best players at the most complicated games imaginable. And these aren't just clever parlor tricks. They are the result of massive breakthroughs, and they're all powered by deep learning.
Right, so it's pretty obvious this technology has just exploded into every corner of our digital world. So let's get down to basics and ask the big question. What exactly is deep learning?
Okay, so at its heart, deep learning is all about teaching computers by showing them a ton of examples, not by hard-coding a bunch of rules. It uses these things called neural networks, which are kind of loosely inspired by our own brains, to find patterns in just massive amounts of data. And that's really the key here. It learns on its own, instead of just being told what to do.
Now, you might feel like this whole AI boom just sort of popped up overnight, right? But the real story is, well, it's a lot more dramatic. It's been this wild roller coaster of huge excitement followed by crushing disappointment. Let's take a look at the history. And this timeline, it pretty much says it all. Back in 1958, the very first neural network created this huge wave of optimism. But then, by the 70s, everyone realized its limitations, and interest just crashed. The field bounced back in the 80s with a clever trick called backpropagation, which let networks learn from their mistakes. But then progress stalled out again, leading to what everyone calls the AI winter. It really was until 2012, with a huge breakthrough called AlexNet, that the modern AI era we're in now truly kicked off.
And just to show you how bad it got during that AI winter, get this. Around the year 2000, if you were a researcher, simply using the words neural and network in the title of your paper made it more likely to be rejected. The field was basically a ghost town.
Okay, so that's the history, the what, and the when. But let's get to the how. How do these machines actually learn? Let's pop the hood and take a look.
So, it all starts with this little guy, the perceptron. You can think of it as a single artificial neuron. It's a super simple decision maker. It takes in a few bits of information, decides how important each one is, and then spits out a simple signal, kind of like a tiny yes or no.
Now, by itself, one perceptron isn't very smart at all. But here's where the magic really kicks in. When you connect millions or even billions of them together in layers, suddenly this massive network can start to recognize incredibly complex patterns. It's the network effect, quite literally. All right, so we've got this huge web of simple little units. But how does it go from that to actually learning something useful, like, say, picking a cat out of a photo? Well, the main process is called gradient descent. And honestly, the best way to picture it is to imagine a ball rolling around a super hilly landscape. The network is basically trying to find the absolute lowest point in that whole landscape, the very bottom of the deepest valley, because that spot represents the point of lowest error or the most accurate guess.
And this learning loop is how it finds that low point. First, the network makes it guess, like, I think that's a dog. Second, it calculates its error. Nope, it was a cat. You were 80% wrong. Third, it adjusts all of its little internal knobs just a tiny bit so it'll be a little less wrong next time. And finally, it just repeats that process over and over, millions, sometimes billions of times, getting slightly better with every single loop.
So this brings up a huge question, right? If these core ideas have been around for decades, what sparked the AI revolution that we're living through right now? Why here and why now?
The truth is, it wasn't some single new idea that changed everything. The revolution was really triggered by a perfect storm, a convergence of three key ingredients that were basically missing during that long AI winter.
And here it is, the secret sauce. First up, massive data sets. The internet basically gave us a library with billions of images and texts for these models to learn from. Second, powerful hardware. In this kind of lucky coincidence, the GPUs that were being built for video games turned out to be perfect for the type of math AI needs. And third, clever software. New programming frameworks made it way easier for developers to actually build and train these super complex models. And when we talk about the scale of these ingredients,
It is just mind-boggling. We're talking about training models on datasets with billions of data points.
And the models themselves, they have become insanely complex. The largest ones now have over 1 trillion parameters. Remember those little knobs we talked about? Imagine trying to tune 1 trillion of them all at once.
And of course, all that data and all that complexity needs a ton of computational power. And that power costs money. A lot of money. Training a single one of these top-tier models can now cost well over $1 million.
So, that brings us to today. This incredible moment of super fast progress. But we've seen the history, right? We've seen the hype cycles. Which makes you wonder, what comes next?
Let's go back to that roller coaster for a second. What's kind of fascinating is that if you look at the history, the previous AI cycles each lasted about 28 years, from one peak of excitement to the next. Our current boom started in 2012. So if history is any guide, that puts us right about at the halfway mark.
And that leaves us with one final, massive question. The last great technology cycle gave us the internet, the smartphone, pretty much the entire digital world we live in today. And we are only halfway through this AI cycle. So, where do you think this one is going to take us?